Merci beaucoup. Thank you very much. So I was born in the 1960s, and I was 5 weeks premature. I had a 50-50 chance of developing this breathing disease known as Respiratory Distress Syndrome, or RDS. RDS is the leading cause of death and disease in premature babies. I was lucky, however. I didn't get it. But if I did, the chances are I wouldn't be standing here right now. Now, Patrick Bouvier Kennedy, the son of President John F. Kennedy, was born in 1963. Like me, he was also 5 weeks premature. But unfortunately, he didn't make it. He died after 39 hours. This tragic story was eclipsed by the unfortunate assassination of his father some 3 months later. But it did bring worldwide attention to RDS. Unfortunately for Patrick, there was no way to actually diagnose RDS and treat it in a way that would have saved Patrick's life. I'm here to talk about how we're changing this. I'm here to talk about a diagnostic test that can actually prevent RDS. And I say prevent. Now, when you hear the term preventative healthcare, a diagnostic test might not necessarily be the first thing that comes to mind. In fact, preventative healthcare was first described here. At least this is where it was first documented. This is text from the Hippocratic Corpus. It's 2,400 years old. It's the oldest known documented medical text. And within it, there's a section on preventative health care. And what do you think they're discussing? Good nutrition. And what else? Controlled wine consumption. Okay, this is France, so I had to say something about wine. So, just like the ancient Greeks, we all know that it is better to prevent disease than to actually treat it. And good nutrition and exercise can certainly help. I'm really passionate about this whole area. But right now, I want to talk about preventative healthcare and look at it from a totally different lens, from the perspective of the earliest newborns, premature babies, because preventative healthcare starts at birth. So, thanks for the introduction. My name is Omer. I'm the CTO at Syme Diagnostics. I have quite a few years of healthcare experience. I have been on an entrepreneurial journey for 6 years. And I meditate. So with that, I would like us all to pause and take one deep breath, and please concentrate when you're breathing. Right now, all together. Now, how did that feel? Didn't that feel good? Mm-hmm. Now, premature babies with RDS are not experiencing this feeling. So what's going on? Surfactant is a mixture that healthy babies and healthy adults can produce naturally. It coats the inside of the lung and enables the transfer of oxygen to obviously assist with the breathing. Premature babies with RDS do not produce a sufficient amount of this surfactant, and that can lead to a collapsed lung. Now, there is commercial surfactant, and a common procedure for dealing with RDS is actually giving commercial surfactant, administering it to the earliest premature babies. But this is pretty much all of the premature babies, the early ones, and this technique is actually complicated, it's invasive, it's risky, and it does more harm than good when you consider that maybe half of the babies don't actually need it. So this is not the right kind of a test. An alternative then is to actually wait until RDS first starts manifesting itself and then treating. but that could be too late, and the baby can die. But if the baby were to survive, the RDS is actually quite debilitating, and it can lead to medical complications, like lifelong medical complications, for a cost of maybe $1 million, maybe more. What is needed is a test, a diagnostic test that can be given to premature babies just after they're born to determine the likelihood that they're going to develop RDS, so that preventative treatment can be given only to those babies that need it, and at the right time. So RDS is a global problem, and there are actually 15 million premature babies that are born worldwide each year. And you can see the relative amounts of RDS in 3 regions. Now, you may have noticed the rate of RDS in China. I want to speak about this because we've done our own analysis, and it seems like the rate is actually coming down in China. But it is also worth noting that it's a big population, and the number of babies in China that die from RDS each year is approximately 42,000. Just to put that into perspective, 70,000 Chinese die of breast cancer every year. So it's obviously a serious problem. Something needs to be done about it. So now I'm going to tell you what we're actually doing about it with the help of a good friend of mine. Okay. Actually, I'm just kidding. But the reason I'm introducing Angelina Jolie is because of a genetics test that she had back in 2013, which revealed that she had a high probability of developing breast cancer. And she took a very courageous decision to have a double mastectomy. And leading experts said that this was actually the right decision. Now, Angelina Jolie did something extremely important. She actually published this story, and she brought worldwide attention to the importance of these kinds of diagnostic tests to actually prevent disease from happening in the future. Even though we're not talking, I'm not going to be speaking about a genetics test. I hope the analogy is clear. So, a genetics test, or most diagnostic tests, would be analyzed in the laboratory with the help of an assistant and some technology. The problem with a laboratory test is time. It can take hours, days, sometimes even weeks. In a life or death situation, that's way too long. Things need to happen in seconds, not in that kind of a time frame. We somehow need to take the complete laboratory procedure out of the laboratory and move it closer to the patient, move it to the point of care. So it all would work in a box automatically without the need for a technician. And that's not all. It has to be incredibly simple, user-intuitive, otherwise busy doctors and nurses are not going to use it. So how do we realize such a new way of doing healthcare, this new type of diagnostic device? Well, it starts with very, very sophisticated product engineering to have a device that can work automatically without a technician. The machine learning algorithm does a translation. If you think that a doctor could quite simply take a sample and put it in the box, the machine would actually process the sample and give a signal. The machine learning algorithm would translate that signal into clinical data that the doctor understands. And then the doctor can take the right course of action. Now, the way it works with machine learning, the more clinical data that are produced, the more intelligent the algorithm becomes and the more accurate the diagnostic becomes. But how do we make that work in practice? Well, we use the cloud technology, okay? The cloud. So how many of you have a smart watch or wear a fitness band? Somebody? Yeah, it's quite a few of you. Now, these devices, pretty much all of them, can monitor your heart rate. And it sends this data from the device to the cloud. And then you can actually read the data whenever you want. But people are developing intelligent algorithms that can actually analyze the data and send if there is a warning or some kind of a problem, they can notify you about it as it's happening. Isn't that important? Isn't that something you would want? So our diagnostic test actually follows the same principle. So what's it actually measuring? Amniotic fluid is the liquid that surrounds the baby in the mother's womb. At the beginning, it starts off mostly as water, but as the baby grows, the amniotic fluid provides nutrients like proteins, carbohydrates, and fats. And this helps with the baby's development. And the swallowing of amniotic fluid is actually quite normal. And when the baby is born, they're surrounded. It's everywhere around them. And amniotic fluid is also analyzed to determine the baby's health. And it can be analyzed to predict RDS. There are two components within amniotic fluid that, if they can be measured, they can indicate the likelihood that the baby is going to develop RDS. And this is what we're actually working towards. So let's put this all together. A baby's born. Seconds count. What does the doctor do? The first thing, or one of the first things that he or she will do, is take a sample of amniotic fluid from the baby, as you see over here. Very, very quickly, they'll rush to the device, they'll put the sample in the device, and in a few minutes, the reading will be given, the clinical data. The doctor will see the data and think, this is a good chance of RDS. They'll go to the baby, administer surfactant, and then the baby's saved. We've actually developed a prototype that can demonstrate it within 15 minutes. And now the next step is to actually make it work in the real world. Now, how is that achievable? I really love this quote because I think it's applicable. The future happens very slowly, then all at once. I think Kevin Kelly, who gave the quote, which I heard on a podcast, was thinking about self-driving cars when he said it. But it's very much applicable to healthcare in general and our problem in particular. Making a change in healthcare is extremely difficult. It requires patience, and it takes time. And there are a number of steps that need to be followed. Try to summarize it here. The first one is clinical data. It's very important to have good quality clinical data published within preferably a leading journal, because that will create awareness and early adoption. We're actually completing a clinical trial in Denmark right now, and we have another one that we're setting up in, guess where? China. And then we have other clinical trials following on from that. But that's not enough. We also have to think about the perspectives of the organizations that will sponsor and promote this new kind of a technology, like the health insurance companies and the government health agencies. So we need an economic model that will help. Once we have these in place, the economic model, the clinical data, then we're in a strong position to say that we have something that improves the standard of care. And it's that point, the actual demonstration of an improvement of the standard of care, that will lead to much more rapid adoption and new opportunities. So what I've hopefully tried to convey to you is a diagnostic test that predicts RDS and can lead to dealing with RDS preventatively. Now, I have to admit something. There are easier jobs than this. It's quite challenging. There are a lot of risks. And it can be painful at times, lots of times. So I often ask myself, why am I doing this? Okay. Well, I have a passion for preventative healthcare. That's one reason, but that's not the only reason. As I said in the beginning, I'm one of the survivors. I'm one of the lucky ones. So it's nice to give back. But it's also this feeling This feeling that I'm giving hope to the customers, that I am helping, perhaps in a small way, future generations, that I'm helping to save the lives of babies, and that I'm able to talk about it to such a lovely audience. It's such a great feeling, and it makes me want to go on. So with that, I'd like to close with a personal thought. Risks, challenges, and pains are part of life. Embrace them, and you can be in charge of your destiny. Thank you.